Thank you. Julian, I have to thank you. You're not only bringing 15 years of experience with you,
sure.
you are bringing the only and one lady we see today for presentation. Silvia, thank you very much. You are carrying a degree in language and management.
To China, yeah.
To China, I think that's also very special. Do not speak Chinese today. English will be nice.
Okay.
There are enough people you can talk to Chinese later on. I'm very sure.
I hope so.
Stage is yours. Thank you very much.
Thank you. So, good afternoon, everyone. I am Silvia Agostini, sales representative at Tera Automation, and I am here today together with Tera sales manager, Mr. Julian Verdi, to present to you our Industry 5.0 solutions applied to new machinery for gold and silver ingots production. So, with the advent of Industry 5.0, we are witnessing a redefinition of the role of the machine, which becomes a collaborative partner, supporting and enhancing human capabilities rather than replacing them. Inevitably, Industry 5.0 stands as a natural evolution of Industry 4.0, while placing greater emphasis on significantly reducing energy and resource consumption and supporting more environmentally friendly production processes. So, Tera Automation has embraced this innovative paradigm and shifted its focus towards efficiency, rather than exclusively prioritizing effectiveness, as has been the prevailing trend so far. Our new work philosophy involves the following targets: Industry 4.0 as a solid milestone, the reduction of machines' footprint, reduction in energy consumption, along with the reduction of consumables for improved corporate finances, as well as reduced environmental impact. But what does it mean in practice? This new work philosophy is mostly reflected in the T-Bar Master, patented induction tunnel furnaces for the continuous production of high-quality gold and silver ingots from 1 ounce to 1,000 ounces. The traditional version of T-Bar Master requires the casting of precious metal grains and involves the use of ingot molds with lids and graphite spacers. So, the first real attempt to innovate the T-Bar Master from a 5.0 perspective primarily focuses on reducing the overall machine's footprint and is embodied in the T-Bar Master power loop. As you can see, unlike standard versions, this model does not develop lengthwise, but is configured as a closed loop. In fact, we were able to reduce the overall footprint of the machine by 45% compared to the traditional equivalent T-Bar Master. The next step was to focus on minimizing consumption and optimizing performance. This approach eventually led us to the question, so why not design a tunnel furnace without graphite spacers? So let's give space to our T-Bar Master Spaceless, the first induction tunnel furnace without graphite spacers. The spaceless concept is geared towards maximum optimization of traditional tunnel furnaces, which means smaller footprint, lower consumption, along with optimum performance. With this new version, we managed to reduce the overall footprint of the machine by 21% compared to the traditional equivalent T-Bar Master. What's more, it is extremely efficient, leading to a 50% reduction in energy consumption. The T-Bar Master Spaceless carries 3 major innovations: the water-cooled telescopic pusher, gate valve instead of pinch valve, along with a high-efficiency, completely silent and compact converter. Let's now take a general look at how it works. So the T-Bar Master Spaceless, the first induction tunnel furnace without graphite spacers. It is a patented solution. It is very compact. So in the standard version, first the operator loads the precious metal grains inside the ingot molds and then covers them. He uploads all the recipes and monitors the entire production process through an HMI panel on the side of the machine. And now the process can start. So the gate valve opens, allowing for the ingot mold to enter the furnace. So they are pushed inside the furnace and then the gate valve closes. Here we observe the interior of the furnace, whereby the ingot molds follow a perfect closed-loop path. The furnace fits 12 ingot molds. So first, the telescopic pusher moves the ingot molds toward the melting chamber. Subsequent pushers then transfer them to the solidification plate and to the cooling tunnel. This furnace is extremely efficient, as we mentioned earlier, since it ensures high performance with very low consumption. Upon completion of the cooling phase, the gate valve opens, allowing for the ingot molds to leave the furnace. So they are pushed to their starting position following the completely closed-loop routing. At this point, the operator can remove the lid, the cover of the ingot molds, and pick up the bars. And as you can see, the final output consists of perfectly shiny and glossy ingots ready for the market. I am now pleased to hand the floor over to my colleague, Mr. Julian Verdi, who will continue with the presentation. Thank you.
Thank you, Silvia, and good afternoon, ladies and gentlemen. So here we have seen a great development of the technology for casting standard Boolean bars up to 1 kilo. But the challenge for us was also to apply the same energy-saving and space-saving concept to production and casting of large bars, namely the good delivery bars, gold and silver. This was possible thanks to the design of the spaceless good delivery version. Here, if you check from the entry arrow, we have a station of the furnace where we load the material. In this case, the material comes from an automated loading system that preloads a batch of fixed weight grains. These are transferred automatically into the mold, and with the same concept of multiple position pusher, they are transferred into the melting chamber. From the melting chamber, we go into the solidification chamber. One very important key feature of this version is the absence of spaces, like in the previous spaceless, but also the absence of lids over the molds. This, in fact, wouldn't be possible, wouldn't allow to transfer the batch of grains directly into the mold. So how can we manage this? In the solidification chamber, there is a heated fixed lid with a mobile motion that covers the mold only in the moment it is located in the solidification chamber. Thanks to this solution, we can assure totally surface glossy finishing of the bar. Once solidification is completed, we go ahead through the tunnel cooling, and at the exit arrow, you can see there is a position with a Cartesian robot that will pick the bar and place it into a cooled table. Here, you can understand better the way it works. So we have the loading system, automatic, with a pre-weighed amount of grains going into the mold. When we solve the process, it will come out from the exit area where there is a Cartesian robot, will pick the bar. This will be still at around 200 Celsius degrees. It will be placed on a cooling table while the mold, the empty mold retaining the heat, will be ready for the next batch of grains and optimize the energy consumption thanks to the residual heat which it holds. So thanks to this development of the spaceless concept, we have reduced footprint, triple efficiency compared to the traditional tunnel furnaces, and of course, no consumables in terms of spaces or lids for the mold. Next step was, we know we can do perfect job with grains, but the dream of our refiners has been, how can we cast directly refined metal, be it silver crystals or gold sponge, whatever. This was our great demand, and the solution has been the one-cast machine, where we have combined two technologies, traditional tilting furnace for melting precious metals, combined with an evoluted version of the spaceless good delivery machine. Namely, we load the crucible of the tilting furnace with a known amount of crystals, in case of silver, for instance, and we target a weight of 30 kg, traditional good delivery bar for silver. Once the recipe is loaded and we start the system, automatically pouring of the tilting furnace will occur and the metal will flow into the mold. The mold itself is placed over a load cell. In real time, it will detect the quantity of metal arriving, and while it approaches the target weight, it will give instruction to the tilting furnace to retrieve its original position. In this way, as you may understand, we can easily, automatically empty the crucible with a full batch of silver crystals and produce continuously, automatically, with no human intervention, beautiful, glossy finished, typical tunnel furnace looking good delivery bars. Here, an overview, a short video of the system working. So we automatically load crystals into the open air crucible. Of course, this is a typical equipment in precious metal foundries, but here you can see how it is combined to the spaceless good delivery concept. So the tilting furnace approaches the tunnel furnace, it will start pouring the metal, and in this moment, the load cell where the mold is placed is reading the quantity of metal entering the mold itself. Of course, we have a target weight. In case of silver, typically it's 30 kg. In case of gold, possibly 12.5. When the tilting has been completed, the multiple pusher already described by Silvia in the spaceless will transfer the mold, in this case, not to a melting chamber, because of course it's already molten metal, but into a chamber where it's going to be homogenized. So we ensure the totally consistency of the melt. Here you can see a little bit more clearly. The first position is where we pour the metal. The second, with the coil, is where it is homogenized. The third is the solidification chamber, where the same fixed lid with a heated cover is helping solidification of the bar. Then we go through the strong cooling in the cooling tunnel and ready for recovery by means of this Cartesian robot. So we have, of course, suitable vacuum gripper. The bar here is approximately 200 Celsius. It is removed by the gripper and placed over a cooled roller table. In this moment, the empty mold is going back to the pouring station at the beginning of the process, which, as explained before, is a great goal in terms of energy saving. This is a typical look of the bars. We can then connect a whole marking station, and here the limit is the fantasy, so you can check the weight, apply a logo, serial number, whatever. And of course, it is a patented solution. We have achieved massive results in terms of efficiency, reduced footprint. This is an example of the difference between the traditional molds for casting 30 kg or 1,000 ounces silver bar with the traditional on top and the one cast on the bottom. And this is a simple table where we can see in overall consumables involved in the process, we have like 80% less compared to the traditional systems. Key benefits, I think I've went through the main ones, but summarizing: reduced footprint, higher efficiency, no spaces, no lids, so ecological and 5.0 compliant. And there is a continuous operation, so fully automated with no operators involved, which means extra safety for the operators. And of course, the possibility of checking the weight in real time while we cast the bars. Key point is the direct casting from crystals to finished bar. That's why the name one cast, because we cast only once, we skip the graining. And this also means great energy saving and time saving. Very quickly summarizing the family of new tunnel furnaces, the power loop, which is responding to the footprint reduction demand, spaceless bar master, the standard version for bars up to 1 kg, higher efficiency and no spaces. The bar master spaces, good delivery for same concept, but with 30 kg or 15 kg, or in general, good delivery bars. And then the one cast that I have just described, casting directly from refined metal. Of course, the actual demands from all refineries are looking for great solutions, and so this means great challenges. We are ready, and this is only the beginning of what we can provide to you. Thank you for your time.